So I think we probably have a number of new folks on the webinar today. So I wanted to say hello to all of them and welcome to the community. We are excited to have you here. And then as the Girl Scout saying goes, also welcome to our longtime followers. Make new friends, but keep the old. You know, one is silver and the other's gold. So thank you all for being here. Just to share with the new folks who haven't seen this before, this is, you know, we do solicit questions beforehand. And so the questions that we'll be answering today are ones that have come from the community over the last few weeks. We do this every month. We took a little bit of a break in December, and we learned our lesson that we probably shouldn't take a break because we had so many questions come in January. So we will definitely not be able to get to all of them today. We will try to get to as many as we possibly can, but rest assured that we have, you know, we know they are in there, they're in the queue, and we will try to make sure that we answer them either in, you know, in FAQs or somewhere else, or next month if we run out of time. We try to focus on content that is new and educational for the community. So anything that is in an FAQ somewhere else or is already on our blog or our website, we will, you know, we will try to avoid those because we want to spare people who have heard that probably more times than they can imagine. And then the other thing that we do not do here is, you know, is to speculate on HBAR. We will let you guys have fun doing that. But to start off with, I did want to have Leemon just address, you know, transaction prices, because as we see some, you know, some changes in the price of HBAR, we have had some questions around transaction pricing for transactions that happen on the network.
Yeah, this is great. So we have always said that there's volatility in the crypto market, and certainly we've seen a lot of volatility recently, which is why we set the prices for the transactions in dollars and convert that to HBARs. And the conversion ratio automatically updates itself as the market fluctuates. And so what it means is that if it goes up a millionfold or goes down a millionth, it doesn't matter. The dollar price of the transaction stays the same. And we smooth out the market a little bit. So the market might get a little bit ahead of us or a little bit behind us, or a little bit ahead of us, I guess, either way. But that's what we do. And so our prices are the same. And so if the coin price triples, the price of a transaction is still the same in fiat. It's just 1/3 in HBARs. But we smooth out the volatility. And so that was something we planned from the very beginning. And I think that recent events are showing that, hey, that's a pretty good idea. So that's what we have.
All right. Thank you, Leemon. So we've got a lot to tackle today. Mance, I'm going to jump right in. The first question is for you. Is Hedera a good fit for CBDC creation?
Right. So many of you may already be familiar with HCS, the Hedera Consensus Service, and that architecture. But as Zenobia said, we have a bunch of new people joining the community. So I'm going to take just a moment to describe that. With normal layer 1 networks, they perform two functions. Transactions flow into the network, and they get put into a consensus order. A stream of ordered transactions is created. And then those transactions flow into sort of the business logic layer, which is normally referred to as smart contract layer, and they get operated on in those smart contracts. The smart contracts operate on the transactions that have been ordered. That has problems in that it can be slow. You have all the smart contracts in the world created by all the developers using that platform, competing for the same CPU cycles on that platform. The information flowing through the smart contracts has to be decrypted. It can't be encrypted. That's a big problem the industry is trying to resolve. So you've got privacy or security, PII concerns, or just information generally you may not want to be public. It's going to be public if it's being operated on those smart contracts. And because of the congestion of the networks, the cost to operate these smart contracts is really high. What we did was we split the smart contracts layer off. You can think of it conceptually, like exposing just the consensus layer and moving the business logic into another network. It could be a private network, it could be a public network. It's just not running on our mainnet nodes. This architecture makes it possible to create a ledger for CBDC with the degree of flexibility and security and privacy and cost structure that you simply can't do on a public ledger using smart contracts for CBDC. So the simple answer to the question is yes. The way in which it would be done, presumably, is that any government that wanted to create a CBDC would create a separate network that manages the ledger for their CBDC. The Hedera Consensus Service could play a role in putting transactions in order and taking advantage of that public ledger trust model. But the scalability, the security, the flexibility in being able to do anything you can imagine in a network for the management of this currency, including KYC, AML controls. You can layer identity on top of it. All of that could be done in a private network. Then, of course, markets that use the token, the coin, could run directly on top of Hedera. There are a lot of sort of secondary or tertiary uses of the coin that could run on top of Hedera directly, but the actual ledger for the coin and the management of that would not be done directly on Hedera. So that's a little bit long-winded, but hopefully that makes sense and gives you a sense of how CBDC would work with Hedera.
Thanks, Mance. Leemon, do mirror nodes need constant human intervention, and will the consensus layer eventually become autonomous like Bitcoin?
Okay, so mirror nodes don't need constant human intervention. All the mirror node is a computer that is automatically downloading files continuously. It checks the signatures on those files to make sure they really do represent what the network as a whole has had as its consensus. And then they parse it out and put it in a database and answer queries from users. So that's what a mirror node is doing. And we've written mirror node software, and some people are running our software. And then some people have just written their own from scratch to read those files and download them and check their signatures and answer questions from them. So that just happens autonomously. If your computer goes offline for a while, when it comes back online, it should just be able to download, keep downloading files and download the ones that it missed and catch up. Shouldn't be a problem. If we change the format of the files themselves, and that of course is something that happens very rarely, but if we do that, then if you've written your own software to parse those files, you need to update your software. So I guess that's manual. But if you're using our software, you don't have to do that. You just download our new software. So it's pretty straightforward. Now that's for our current mirror nodes. We do have a different kind of mirror node that we may have in the future, where your mirror node is just like a node on the network. And in that case, I won't go into all the details, but it should be able to do the things that the network does, where it can automatically reconnect when it drops off, and it'll be more interesting. Just gives you lower latency and gives you state proofs and things, but we don't have state proofs yet. But when we have state proofs, we'll be improving the mirror nodes to allow you to have state proofs from the mirror node itself. But right now, what you can have is sort of like a state proof. You can get from the mirror node the signatures on one of these files, and then you can look in the file to see the information you're interested in. So what will be changing in the future is a more fine-grained one. But that will also be pretty autonomous, and then even the software updates will be autonomous. As for the mainnets themselves, the nodes are autonomous. To upgrade the software, right now what we do is have a human load the new software in. And so a lot of ledgers work that way. If there's going to be a new software version, you have to download it and decide whether to load it or not, and you do that manually. We have code on the network that we haven't used yet, but we're debugging it and working with it that'll let even that happen automatically. And so even the software upgrades will happen with no human involved at the node. It'll just happen automatically if it is triggered by a transaction that was signed by more than 2/3 of the nodes. So the consensus will do it. And so that'll be coming. But right now, the way it works is that a human updates the software. But in the future, even that will be automated. So that's where we're headed.
Thanks, Leemon. That's helpful. Mance, our next question is on one of my favorite use cases, the Coupon Bureau. Can you share any more about when the Coupon Bureau will be going live and what their transactions might look like on the network?
Yeah. So for those that don't know about the Coupon Bureau, it's an organization that is working with the largest consumer packaged goods manufacturers in North America to update the way coupons are managed. And they're using Hedera to provide that layer of trust so that all of the different participants in sort of the supply chain of coupons have transparency into the coupons and how they're being used, and the fact that they're used, it reduces fraud, increases efficiencies. It's a really cool use case. So they are going live. The first retailer, I should say, is going live on February 1st, is my understanding. So that's when we'll start to see some of the redemptions happening. I suspect and believe that we should already be seeing mainnet transactions from certain brands that are registering their coupons. I think that's happening today. We'll start seeing retailers come online over the coming weeks and months. And we, I believe they expect to be onboarding some pretty large tier ones as well during that time. So I don't know exactly what those transaction rates are going to look like in terms of TPS, but we should start seeing some numbers soon. And I think that there have already been some number of transactions on the network as they set up the database.
Thanks, Mance. And we have a note from Jay Johnson from the Coupon Bureau, who notes that the demo is Feb 15th. So thank you, Jay. All right, Leemon, is there a threat of attack by manipulating the time protocol and or the servers?
No. So let's talk about this. This is really interesting. So imagine, first of all, in the consensus, we use timestamps, right? You take the median timestamp on an event, and that's what we use to put them in order within a round. And then that gives you your timestamp, and it's a fair timestamp, and it's really cool. For fairness, you need most of the computers having sort of accurate times, roughly. But what would happen if an attacker could completely control the clock on every computer in the network? So every time the computer asked its clock, what time is it? The attacker could make it always say 0. It's always time 0 for everybody. Or he could make it be random and say, well, first I say it's time 0, then I say it's 1,000,000 years from now, then I say it's 1,000,000 years ago, and it's random every time I ask it. It isn't even in order. If I ask it the time several times in a row, it doesn't even give me answers in order. Or maybe the attacker makes every computer in the entire network always agree that we're in the middle of the Middle Ages, and it's a long time ago, or we're 1,000,000 years in the future. I'm not sure we have enough bits actually for that, but convinces everybody that it's 1970 right now. Would that hurt us in any way? It would have zero effect on the speed at which we get consensus and the consensus of our consensus. We're all going to get the same answer. So what will happen in any of those attack scenarios is that when you submit a transaction, it will still reach consensus just as fast as it always has. We will still put them into consensus order. The consensus order will still be uniform across all of us. We all agree, all the nodes agree, you can still trust it. The network will be just blazing ahead just the way it always has. There are no problems at all. You will, of course, I would assume, start getting some nonsense times. You'll start seeing, my transaction happened in the year 1,000,000 or whatever. Because of course, if all the clocks are wrong, how would it know what the time is? But you'll still have a guarantee that all the nodes agree on the time of each transaction, and that every transaction has an official consensus timestamp that is later than the one before it. They will always be in order. Even if the clocks give you numbers out of order on every single computer, the transactions themselves will have times in order. And so we have very strong guarantees about that. We even have a low resolution fairness. If you submit your transaction and then 3 seconds later it has consensus, and then I submit my transaction, mine will definitely come later than yours in the consensus order. So, with a 3-second resolution, we even have sort of like fairness. What you lose is the fine-grained fairness. The fine-grained fairness says if my transaction reaches all the nodes in the network, or most of the nodes in the network, a little bit later than yours, even a tiny bit later, yours should count as coming first. And that fine-grained transaction fairness is what you would lose if we didn't have clocks. And that's why we use clocks in the protocol. But the protocol itself, the Hashgraph algorithm, would work absolutely fine if you got rid of clocks entirely and just set the clock on every computer to always be 0 and just ignored the clocks. So I'm not worried about attacks. Now, the other good news is that if most of the nodes, more than 2/3 of the nodes are honest, and they're doing their best to get the right time, but some clocks are a little bit fast and some are a little bit slow and some are a little bit off. What kind of a time do we get? Because we're taking the median, it kind of averages out all the errors. And so you'll actually find in that scenario that the consensus timestamp is more accurate than any single computer's clock. That would be what you would expect. And so on average, if you were to ask one computer, when did this message reach most of the nodes, if it could actually spy on all the nodes, it would even be less accurate than what we get from Hedera, because Hedera is using the median of all those clocks. So this is great. We don't need the time protocol. Consensus works fine without it. But if you care about the timestamps, like you have a legal contract that says this has to be done by noon on Tuesday, then our timestamps are very reliable and they give you low resolution fairness automatically. But if you have even roughly good clocks, they give you high resolution fairness. So that's what we have with the timestamps.
All right. Thank you, Leemon. Mance, next one is on council members. Do council members share applications that they develop between themselves? So for example, DLA Piper has recently talked about their Toco platform for tokenization. Are other council members trying to use Toco within their tokenization efforts?
Yeah, so I certainly expect that to happen. What's happening now is that the special interest groups have been meeting for a few months, maybe it's that long. And there's a range of participants across the special interest groups. And they are learning from each other about their product offerings, about how they're using the network. There are synergies that sort of develop and hopefully emerge through the SIGs. One of those, for example, so the first three that we focused on was identity, data integrity, and tokenization. And what we're learning is that as we look into these SIGs, there are a lot of common use cases. Some of the same use cases are used across, all three different areas. And so there's this discovery phase that the members are in, and even some third parties that are invited to come in and participate are contributing in this way. And now we just kicked off, or we're about to kick off. I'm not sure exactly on the status of this. I know it's happening, that there's going to be another SIG, and it's vertically focused. It's on the telco space. So I don't know the full extent that the members are working with each other. I can see the interactions when I'm involved. And I would anticipate that, yes, there will be the synergies that are sort of implied by the question.
Thanks, Mance. Yes, it's very exciting to see this all develop. Leemon, why the shift away from on-chain smart contract execution? Aren't on-chain smart contracts a critical part of DeFi and gaming and other applications?
Great question, because logic is a great part of those, but there's multiple ways to do logic. So we do smart contracts, but we have other ways too. So smart contracts have been there from the beginning. They're still here. They still do exactly what they did on day one. There's nothing wrong with them. They haven't broken, and you can still use them just like you could in the beginning. And lots of ledgers have smart contracts, and you can use them for lots of purposes. And so maybe there are use cases where you would want to use our smart contracts, and you can do it. But it is inherently the case that smart contracts end up having to run serially. They end up having to run on every node in the network. And there is a limit to how fast you can do that when every node is doing the computation and it is being done serially. There are also limitations on how much privacy you can have with a smart contract. There are some things you could start talking about doing with encryption and even homomorphic encryption, but that's going to be incredibly slow. So smart contracts are a great tool, but they don't do everything. And what you really want is a way of doing this logic much, much faster than just a vanilla smart contract running on a mainnet. And so what everybody has been doing around the world is finding various ways that you can offload it in a way that still has the trust of the mainnet. And so we have layer 2 ways of doing things. And what Hedera has created and allowed people to do is the consensus service, which is better than a typical L2 system. In a typical L2 system, you do all the computation off on the side, and occasionally you update the mainnet on what happened. But what we can do is kind of invert that model. We can do the computation on the side and keep all the data there, but let all the transactions flow through the mainnet to be put in order. Now, just doing the transactions is incredibly fast. If all you're doing is taking your smart contract calls and you're just passing those calls through Hedera to have Hedera put a timestamp on it and put them in order and be able to cryptographically prove that it happened, that's incredibly fast. And so what you do is you use an AppNet, using our consensus service, you use the AppNet to do the actual logic and to store the data, and then pass everything through the mainnet so that you get the trust of the mainnet on it. And so that is sort of a different approach than L2. L2 approaches would also work with us, of course. You can always use our file system to store some information and update it only occasionally, or have a smart contract on us that you only call occasionally to update from some smart contract running on some other network, some local private network. You can always do that. But HCS gives you another way of doing it. And so you can run a smart contract on us, or you can do traditional L2 systems, or you can do the HCS, which gives you incredible speed. It also gives you privacy. In a smart contract, as traditionally written, you can't have any secrets. A smart contract can't know a secret private key that is kept secret because of the nature of how it works. But if you're doing this on an AppNet and you encrypt everything flowing through Hedera and the AppNet is permissioned, you can absolutely keep things secret. And so you can get some of the benefits of a smart contract that's public with some of the benefits of private code running. And so that's what we're doing. So it's not that we don't have smart contracts. They haven't disappeared. They're still here. And then as the whole world is building ways of making them better, we also have ways of making them better. And we can do them better the same way other people do, but we can also do them with the consensus service. And so you have a whole range of choices. And which one should you use? It depends on your application.
All right, choose your own adventure. Sounds good.
Choose your own adventure.
Mance, what are some reasons that may delay future council members' readiness to announce their membership and therefore to start their initial 3-year term?
Well, so I'll answer that, but I also want to take an opportunity to sort of update the community on the process. I've talked about this in the past, and we have made another improvement to the process. So let me describe that, and then I'll answer directly the question. We now have a separate admission date. In other words, when their membership, a new council member, when their membership term actually starts, when they're actually admitted to the council, in addition to an effective date. So the effective date is when an agreement is signed. In other words, we have a contract where they're effectively joining the LLC. They're becoming a member of the LLC. We've signed that. I can now countersign it. That's what's new. The prior, when we talked about this last, I described the process where they would sign and then I would countersign. And the moment I countersigned, they become members and it would be announced. Well, that created other problems. And so we now have an admission date separate from the moment in which I sign, or the effective date. I can now countersign, we can have that behind us. And then when a new council member decides that they're ready to publicly disclose that they're a council member, that's the admission date. That's when it becomes the case that they're part of the council in a meaningful way. It's at that point when the 3-year period starts. So why would they want to wait? In the experiences I've had, it revolves mainly around their readiness, in most cases, to talk publicly about their plans. Not just the fact that they are joining Hedera, as a council member, but that they have a use case in mind, or they're doing something more generally in the space of distributed ledger technology, and this is part of a larger announcement. It really has nothing to do with them wanting to delay the start of the 3-year term. I don't think that matters. It has more to do with their own comms program and readiness to announce to the world, perhaps not just the fact that they're joining Hedera, but what that means in the larger context of their overall strategy and what they're doing. But it doesn't always happen. It's often the case that they sign in the admission date and the effective date will end up being the same. I'm anticipating that would be the case as well. So that's the experience we've had so far.
All right. Thank you, Mance, for clarifying that.
I'd like to clarify my last question before you ask me another question. So this is kind of fun. Homomorphic encryption is fascinating. If you want to run a program on every node in the network and not have the network nodes know what they are running, if you want to keep it a secret from the computer running the program, that's called homomorphic encryption. And it can be done, there's partially homomorphic encryption. There's ways of just doing certain operations that you can actually keep secret from the computer that's running it. And you can always do that. But if you want to run a general purpose program, like an ordinary smart contract, you want to take an arbitrary smart contract in any language and be able to run it. In other words, if you want it to be Turing complete, which means it can do anything, then you'd have to use fully homomorphic encryption to keep it a secret from the computer that's running it. And if you want to do that, I actually worked on this 20 years ago. I was doing research on this. Just recently, a few years ago, someone actually invented it and actually got it working. It was immensely exciting. I am really excited about fully homomorphic encryption. However, to run an ordinary little smart contract call would take many, many hours or days or months even on a computer to do it in a fully homomorphic way. No one knows how to do that practically right now. Now, there are ways of encrypting databases where you can do just a certain number of operations and still hide it from the person running the database, in the computer running the database, or there are ways of doing just certain operations like that. But if you want to run general purpose programs and you want to keep it secret, right now what you have to do is run it on a computer where that computer is keeping the secrets, where the computer can see the secrets, but it doesn't tell anybody else. And so that's why you would use HCS for that. You can talk about doing partial versions of that at the native layer of Hedera, but it will never be able to run fully general programs until we have fully homomorphic encryption working fast. And I don't know if that will ever happen, but it certainly hasn't happened in the last few years. So that's what I wanted to explain, is what I was talking about, is fully general Turing complete programs. Just humanity has not yet figured out how to do it. There's some reason to think we'll never make it really practical, but yeah, today we can use HCS and you can get the exact same effect in that way, which has been incredibly fast, super fast, and completely secret. Okay, so I just wanted to clarify all that.
Thank you, Leemon.
Go ahead.
Okay, we'll keep going, Leemon, but we'll switch gears a little bit. Do you believe Hedera will be part of the future world monetary system? And if so, to what degree?
Oh yeah, so this is absolutely coming and even accelerating. I love this. In the U.S., we just recently, the government told the banks you can start doing things with ledgers. You can run nodes, you can have stable coins, and you can hold digital assets like this. So the world is clearly moving to where ledgers are the mainstream. This is part of why we've seen a recent just explosion in the market, because this is becoming mainstream now. What will end up happening is the entire world's financial system is going to do whatever is the fastest, the simplest, the lowest friction, the lowest cost, the best convenience, all of those things. And clearly ledgers are part of that. And so it's clear the future of the world. Hedera is poised to be extremely important in this because it's so fast and it's fair and it's well governed and all sorts of good reasons for this. So yes, I think it will become part of the international financial system in great ways. From you use your credit card to buy something on Amazon, but it's actually HBARs doing the buying, to governments standing up CBDCs, which might be on a private network that then hooks into public networks and combine and communicates with them in various ways. I think Hedera is going to be at the center of all this. And I just am very excited to see now we're seeing it happening. We're seeing the world actually start to move to having ledgers play a role in the world. And we're going to see a lot more of that.
Thanks, Leemon. Okay, Mance, speaking of real world use of ledgers, can you tell us where the daily transaction increase is coming from?
Yeah, so what I can't do is tell you a list of names. There are multiple sources for the TPS, some of which we do know by name, but many we don't. We simply don't know who is using you don't have to tell us to use the network. Anybody can just go and make API calls. Developer can build a dApp and run it, and we don't know who they are, and it's just network is being used. That's by design, right? So I'm aware of multiple organizations that have recently started adding TPS to the network. And in some cases, I expect that TPS to persist and grow. And in other cases, I think it will sort of ebb and flow. And those companies, not all of those companies that have added TPS have fully developed their products or business models. And I'm aware of that as well. So I would say that not all the applications that are deployed today on mainnet are fully productized and deployed. So again, you should just sort of expect that the TPS rates are going to be volatile in the short term. They may surge and they may diminish. I personally am expecting that kind of behavior in the short term.
All right, thanks, Mance. Leemon, if the American government, its agencies, and affected corporations had been using the Hashgraph platform, would the recent Russian hacking have been obviated? And I think by this, they mean the SolarWinds attack.
Okay, so let's just talk about hacking in general. So hacking in general is involved in stealing information, or in going in and changing information on a computer, or in going into SCADA systems. SCADA is things like power grids and railroads and dams and water, infrastructure control, where computers are controlling those things. Hacking can get into those. So hacking is kind of a broad thing. And ledgers are not a panacea. A lot of these things have nothing to do with ledgers. So if someone is stealing your information, ledgers don't really help. You can put your information on the ledger and encrypt it, but then the security isn't coming from the ledger, it's coming from the encryption you did. So ledgers don't really help with that. I mean, public ledgers, private ledgers, of course, can be kept private, but public ledgers don't really help with somebody stealing information. If you're talking about control systems for SCADA, then ledgers don't themselves help. What you really need to do is have strong authentication when you log into the dam and you try to open up the sluice gates. But that might involve public key infrastructure where you sign your transactions or your commands with a key. And that might involve strong identity systems. And ledgers can play a role in that. They can help us build up strong identity systems and keep track of like revocation lists. Have your keys been lost? You can just report that they've been lost and now nobody will ever use them again. And with a ledger, you can make sure that information goes out immediately and very fast. So there are ways that ledgers can be part of a strong identity system. And I think the planet needs a strong identity system, and we'll get there. And Hedera will play a part of that. And is already. We're already involved in standards for identity on ledgers. And for keeping secrets, well, the ledger itself doesn't keep secrets if it's public. The whole point is to be public. But you can always encrypt stuff that you put on the ledger, but then it's not the ledger helping you. For preventing people from corrupting information, the ledger can keep information immutable, or even better, control mutability, where it only changes when it's changed by an authorized person. There, a ledger can help, unless you lose your keys. So if the hacker is able to get your keys, then of course the ledger hasn't helped a whole lot. But it can help from some kinds of attacks. So there's limits to what a ledger can do to stop people from hacking into your laptop. If they can hack into your laptop, well, ledgers can't really do a whole lot if they can get your keys and so on. And you could say, oh, we'll store the keys in a special chip in the laptop itself. We'll have a trusted execution environment. We'll make sure that the keys are stored there so a hacker can never get the keys. Okay, but if the hacker can hack into your laptop, they can use those hidden keys to sign anything they want, which is just as bad as getting the keys. So the world of hacking is a big area, and ledgers can maybe play some roles at the periphery of it. They're not a panacea, And most of what we talk about with hacking really is unrelated to ledgers. But yeah, they can help somewhat, especially in the identity parts of it.
All right, lots of pieces to that.
Lots of pieces.
That puzzle and that challenge. Thank you, Leemon. Mance, Michael Saylor said that software will consume the world. Do you believe this to be true? And how is Hedera ready to be a part of this global digitization?
Yeah, so Michael may have said that, but the original quote goes back to Mark Andreessen, I think a couple decades ago. And what I would say is that software has already consumed the world. This is not something that's going to happen in the future. It's happened. What's new is that the world will become tokenized. That's what's exciting. Everything you can see, everything you can touch, and many things that you can't see or touch will be tokenized. If it's a product or a service, if it flows through a supply chain, if it's information of any value, then it is going to be tokenized. So think of a public ledger as supporting a massive global database of records of information. Each record is represented by a token. These tokens are designed for economic activity. That implies that you can transfer the value of the record from one party to another. So what does that mean if we think about interoperability between ledgers? All right, we're simply saying that the transfer of these tokens needs to be able to take place across ledger. So the interoperability layer is enabling the transfer of tokens or these records in this massive global database from one ledger to another. It's like moving a record from one database to another. So by representing the record as a token, we make it really simple to transfer the value of that record from one party to another. And because transferring a token means that we're transferring value, then what does that imply? It's critically important that we guarantee that the token can't be cloned or duplicated. In other words, there can only be one copy of the token that exists at any given time. This is the difference between a normal database and distributed ledger technology. That's what Hashgraph and DLT more generally enable. That's the future, right? The world's already been consumed by software. It's about to be taken over by tokens.
Thanks, Mance. And while we have you on a roll talking about vision, have you conceptualized what Hedera will look like in the future once it's almost or fully complete?
So I guess just to what I just described is the vision of the future, right? It's what I believe, what I think we believe, Leemon and I believe the future is going to look like. But to make it a little more general, it's a planet-wide utility. Hedera is a planet-wide utility. It will have an effect on every part of the economy with everything of value accessible from the ledger. Identity will be on the ledger. There'll be proofs of published information on the ledger. Anyone at any time can carve out, you've heard this before for those that have been with us from the beginning, anyone at any time can carve out their piece of cyberspace and build and work and play with those that they invite into that universe. What we're now seeing are the mechanics of how we realize that, right? We started with a vision and we knew that we would somehow get there. Now we're seeing at finer grain detail how all that plays out. And again, it's all about tokenization. The future is a tokenized universe.
All right, thanks, Mance. Planet-wide, but also possibly for Mars.
Possibly for Mars. I'm sure somebody will tokenize Mars. You can already buy a star. You can buy a star, on paper, somebody will tokenize the universe. Yeah.
I feel like that might have been a plot of a Minions movie, but we digress here.
Yeah.
Okay.
We will tokenize ourselves, right? I mean, we can point to Spencer Dinwiddie, who's already going down that path and sort of creating the platform that makes it possible for content creators, or I forget what he calls them, those that have contracts to tokenize those contracts for the work that they're doing, right? This is the world that we're moving into.
Yes, indeed. All right, and as we move into that world, Leemon, what are the bona fide comparative advantages that Hedera has compared to all other DLTs, cryptocurrencies, et cetera? What are the overriding features that make Hedera the best choice?
So it's fast, fair, secure, and well-governed, and this really does matter. So we can do many thousands of transactions a second, which lets us charge 1/100 of a cent to transfer cryptocurrency. This matters. You can do transactions at 30 cents a piece, but it's 1/100 of a cent. It's allows you to do new kinds of things you couldn't do before, and it's extremely fast. And the consensus service lets you harness that speed to run arbitrary code on other networks, even keep it secret, but still have that speed in the security of Hedera. And it's well governed. These council members that run it, that own it, that control the roadmap of it, are scattered around the world. They're in different countries, under different jurisdictions, on different continents, in different cultures, in different fields, different markets, different industries. And so they are checks and balances on each other, but they're also extremely large corporations that have been around for a long time, that know what they are doing, and are not going to make stupid mistakes. Well, they can make stupid mistakes, but as much as we can, two heads are better than one, and the council is going to be the best that we can get for making wise decisions. And I said companies, it isn't just companies. So we have UCL, we have schools, universities, which gives another perspective, and we'll talk more about those things. So I think that the governance is important, the speed is important, the being inexpensive is important, the latency, I didn't even say that, just a few seconds to finality, and it's true finality. Asynchronous Byzantine fault tolerance means it's guaranteed to be finality. It's not going to roll back. I have to laugh at the FUD this week. People were saying that Bitcoin did something wrong. Bitcoin didn't do anything wrong. It just had to roll back. And I think it was only one block or 2 blocks. I think it was only 1 block. It's just nothing. So FUD gets out there. Bitcoin didn't do anything wrong. And I heard FUD about us too, that it takes an hour to reach finality. Nah, 3 seconds. Not an hour, 3 seconds. So lots of FUD goes out there. But we do get finality in 3 seconds, and we do have finality is final. You never have to roll back. We never have to say, well, you thought you got the coin paid to you, but it didn't really get paid to you. So those are all features that we have that I think are important.
All right. Thanks, Leemon. Mance, the next one is a clarifying question for you. We have a listener who thought he heard you say that we shouldn't expect all the tokens will ever be released. Can you clarify?
Yeah, so we've published a timeline for when we will be releasing tokens for which we have contractual obligations. And I think actually we're going to do an update to that same document in the next month. My understanding is that in February, we're going to publish an update to that document. So we do have contractual obligations. We've already told the market, what those obligations are. We do expect that the council members who are responsible for Treasury will eventually release all of the tokens from Treasury, but it's up to them to govern this, and they will decide when or if it will happen. Outside of the contractual obligations, we don't have a set in stone time frame for the release of Treasury. And it's for that reason, when we publish those documents that many of you have seen, we only show what the contractual obligations are. So the expectation is that Treasury will eventually totally be released to the market. There is no thought about what that will be beyond what we published in the contractual obligations. And it's up to the members to govern that and decide it.
All right, thank you for clarifying that, Mance. Leemon, do you think sovereign nations would generally be for, against, or neutral about running their digital currencies on Hedera, which is, as we've talked about a lot, a DLT governed by a group of large corporations and others?
Oh, I think Hedera will be involved. So every nation so far that has talked about CBDC has talked about a model where they run their actual currency, the balances of the currency, on a private network run by that government. But the whole point of doing it is to then be able to interoperate with other ledgers. And so what you would imagine is that you don't have the balances of the US dollar currency or whatever running on Hedera. I mean, you could do that. And maybe there's a nation that someday will say they want to use a public ledger for that. But that's not typically the model people talk about right now. You would imagine they run their own one on computers that they run. But the whole point of doing it would be so that it could interoperate with people like Hedera. And so that you could have markets and stock markets and selling and buying things and transfers of things happening on Hedera using that token from that private network run by the government. And so that's typically what you envision. And Hedera, I think, has a great role in this because HCS gives you the speed so that you could do that. And Hedera has very low costs and I think is going to be a very natural thing to be using for things like markets where you want to be buying and selling things using the tokenized fiat as opposed to the tokenized fiat itself being on Hedera. Though, of course, you would have wrapped tokenized fiat on Hedera. That's how the tokenized things would interoperate with all the different ledgers. And so I think that Hedera will be playing the role just like other ledgers will in that, and that Hedera is well poised to play that role.
All right. Thanks, Leemon. I know we are getting close to the top of the hour. Let's try to squeeze a few more in. Mance, did Jordan leave on good terms and what is he doing? It seemed like he was going to make a lot of noise about his new venture. Then he changed the name. Now it's a little quiet. Tell us what's going on.
Yeah. So we are on fantastic terms with Jordan. He did leave on good terms. We speak regularly. There's absolutely no bad blood there with Jordan. And that's not why he left. Hedera can't really speak for what Jordan's doing, but we do understand it will be supporting the Hedera ecosystem and building infrastructure around HBAR and the Hedera network. He's been gone for a couple of months now. My understanding is that he's hiring a team and standing up his organization as we speak, and he'll be sharing much more over the next few weeks, the coming weeks. So yeah, no, everything is good with Jordan.
Great, thanks, Mance. Okay, Leemon, do governing council members operating as nodes have access to information on the transactions that is different from what non-governing council nodes have? Are all network nodes equal other than their proof of stake clout?
Totally equal, no extra information. When you submit a transaction, the entire planet sees all the bytes of that transaction, and that's all that the nodes see about it. I suppose if you were talking to one node, it could theoretically look at what your IP address was if you're literally talking to that node, but we don't even do that. We don't even collect IP addresses. We don't even collect any information that we could have. And we have councils running nodes. When other people are able to run nodes as well, the nodes will be completely equal in every possible way, aside, as you say, from stake. Different nodes may have different stake. But aside from that, they will be completely equal. They will all have the same information. The only secrets are each node has its own keys that it uses to sign what it's doing. So the other nodes know that that can't be impersonated. And aside from those keys, that node has no secrets, nothing different from any other node. And it's all equal.
All right. Thank you, Leemon. Now going from governing council sort of logistics and details to bigger picture, Mance, Hashgraph has the potential to disrupt the business models of some of these governing council members. Are they willing and able to pivot their business models? And have you seen any evidence of this?
Well, look, I can't speak for our council members. It's going to be a very short comment. I do find it interesting that one of the world's largest law firms who makes their money by billing labor hours has created a product, right? DLA Piper has gone to market with Toco, which is a product offering. It's a platform. It's not your sort of traditional way of making money inside of a law firm. So I wouldn't say necessarily that I expect their business models to be disrupted. I mean, maybe it's the case in some verticals, but I think that the council members are with us so that they know how to change their models if needed and to take advantage of this emerging market, this emerging space that we're in. So I view it as a very positive thing. I think it's all good. And yes, I would expect new models to pop up in every vertical, and all enterprises, all businesses will end up reacting to that same way that we did globally with the advent of the internet and all that it brought around. So that's just a normal process.
All right. Thanks, Mance. Leemon, we have a question, again, maybe more of a clarification on HBAR. It's my understanding that to secure the network in an environment where nodes can be added freely, HBAR must have a minimum price, which makes it uneconomical to acquire sufficient HBAR to disrupt the network. What, in your view, is that minimum price, and how likely is it that it will be achieved, taking into account that Hedera services are quoted in US dollars?
It's not exactly a minimum price. What it is that it should be hard for an attacker to get a third of all the coins in the world. And this is after we've released all of Treasury. So before we released all of Treasury, they would have to get a third of all the coins in existence. So until we've released it, they can't get a third. After we've released a third of the coins, they could theoretically get a third, but they would have to buy up all the coins, or a third of the coins in existence. And in order to do that, they'd have to go out and start buying, but the very act of buying makes the price go up. So the price doesn't have to be high today. The price just has to be such that we believe it would go up a lot if someone tried to corner the market on it. And then the cost to corner the market on it has to be balanced against how much profit they're going to make from this scam. And so, if they can only make $1 million on the scam, then it better not cost them more than $1 million to buy a third. Otherwise, they just won't do it. And so you'd have to find a scam that they could make a lot of money, so much so that it's worth risking it by spending less than that amount of money to corner the market on HBARs. That sounds hard. Even today, that sounds hard to do. And we haven't even released many of the coins. But even today, I think it would be extremely hard to corner the market on HBARs, for one person to buy all the HBARs. So that's what we're talking about. It would appear that HBARs and even other tokens out there, it would be hard to go buy up a third of them right now. So hopefully that will continue to be the case, or become even more the case.
Yeah, I'm just going to piggyback on that for just a moment. The network is secure as long as the nodes are permissioned. And that doesn't mean it can be restricted or has to be restricted just to the governing council nodes. There can be thousands of permissioned nodes, and the network would be secure independent of the whole topic that Leemon just addressed.
Yeah. So we're totally secure as long as we're permissioned. We're also totally secure before we've even given away a third of the coins, because then no one can get a third of the coins. And then even when we give away all the coins and we're not permissioned, we're still secure. If it's harder to get a third of them, it would cost you more to get a third of them than you would make on your scam. So multiple levels of security there.
And I'm sorry, just one more clarification. When we talk about permission, we're not talking about people going through KYC to create an account on the network. We're talking about the nodes that are participating in consensus. As long as those are permissioned, then we're secure.
Yeah, I heard someone misunderstand recently, thinking that you had to be permissioned and do KYC to get an account on Hedera. That's not true. You can get it totally anonymously, and there's even places you can get it for free. Many of the wallets will actually create an account for you for free and totally anonymously. No, we're just talking about running nodes.
All right, let's see if we can squeeze in one, maybe two more here. Mance, what's the right way for a service provider to offer proof that anonymous data gets stored safely and for personal use for its users? Specifically, what service from Hedera would best suit this purpose? So
I would point you to, in fact, Zenobia, if you would paste that URL into the chat, Manitou. Manitou has a consumer privacy management platform. It automates data privacy and compliance. And they do so, of course, using our platform. It's for managing consumer requests. Manitou has audit logs to memorialize each and every request that comes in from consumers and end users, and then the enterprise's response to it. So I think this is what you're asking about. I would go and take a look at Manitou.
All right, I'm going to push one last one for Leemon here. Can blockchain be used to certify and secure IP rights in lieu of patents or copyrights?
Not exactly, because I mean, you couldn't do it in lieu of patents, because the whole point of a patent is that the patent office says, oh, your patent really is describing the same thing as his patent, even though they were written in totally different words, and then use the legal system to enforce that. So you wouldn't do that. You could, under a first to invent system, use it to prove that you invented something. So it used to be that people would invent something, they would mail it to themselves by certified mail just to prove that they had invented it on a certain date. And then later when they filed their patent, they would get a credit for that earlier date. You could use ledgers for that. But the US went away from that system. It went to a first to file. Now it's just whoever files with the patent office first. And so the ledger wouldn't be helpful there either. So probably the ledger isn't terribly useful for that. But the patents themselves can be put there as an immutable record. You might use this for storing things like that, or a hash of it. But probably not the patenting process itself. You probably wouldn't use ledgers for that.
All right, thank you, Leemon. I know we didn't get to some of the fun personal questions that we normally do, but we will try to hit some of those. We thought it was important to address the ones that we were able to cover today. We did get a number of questions on predictions and thoughts for the upcoming year. I'm going to post in the channel Mance's piece that ran in CoinDesk that shares some of those as well. So hopefully, you all will be able to take a look at that. We also got a number of questions around, jobs at Hedera, and I have just posted as well the link for that in terms of open roles. Again, thank you. We definitely had a full docket today. We will do this again next month. So look for, the email, and please do share your questions there. And again, as always, thank you to this community. We are so appreciative of you and everything you do. And we hope that you are staying safe and well.
Thanks.
Yes, thank you. Stay well.